Good day, and welcome back for part 2 of the presentation on data integrity, now covering the Alcoa Plus and the FAIR principles. My name is Martin C. Michel, and I represent the Department of Pharmacology at Johannes Gutenberg University and the Partnership for the Assessment and Accreditation of Scientific Practice in Heidelberg. If you have not yet done so, please watch part 1 of this video for the general Alcoa recommendations. We'll now talk about 4 parts of the recommendation that were edited later on. The first one stands for complete records. Are all data included, including any repeat or reanalysis that may have been performed? Data must not be deleted after the date of documenting and include any changes as well. This is important because only complete data represent the true findings. In practice, that means to completely report all data obtained and be transparent about any data and experiments being performed. This includes outliers. There's nothing wrong with appropriate means to remove outliers as long as you are transparent about it. The second part of Alcoa Plus stands for consistent. Are all elements in chronological order and as planned? All elements of the analysis must be in the sequence of events as occurred. This is important to understand the experimental procedure underlying your data. In practice, that means to organize your data according to date and time. It is very helpful to reduce errors by applying standardized operating procedures, also called SOPs, wherever possible. Endurable. Are all recordings and notes accessible over extended periods of time? The material used to record the data must be in a manner which will last a long duration of time without losing readability. For instance, at least in my age group, we started using computers when we still had 5-inch floppy disks. Many of you will no longer even know what that is, but that also implies that any data stored on such media will no longer be useful, as this is not endurable. This is important because data could be the basis for future research products. They could also become part of an audit in case your discovery becomes important for the development of a new medicine, and upon asking authorities to approve this medicine, they may wish to go back to the original findings and audit them. In practice, it means to have an appropriate data format and use a medium lasting for the desired time period. The next one is available. Can the data be accessed for review over the lifetime of the record? Data must be accessible whenever needed over the life of the data. This is important to share the experiments with colleagues, but also to enable the possibility to reanalyze the data or repeat the experiments. In practice, it means to securely save experiments on long-term storage. Data should stay in the institution where they were generated. Data generated by temporary researchers should only accompany them as a copy and ensure readability of the file format. So, to summarize the Alcoa and Alcoa Plus principles, are the data attributable? Who acquired the data? Are they legible? Can you read the data in any entries? Are they contemporaneous? Was it recorded as it happened? Are they original? Are raw data records saved as well? And are they accurate? Are all the details correct? The Alcoa Plus principles, are they complete? All data included? Consistent? Are all elements in chronological order? enduring are all recordings and notes accessible over extended periods of time? And finally, are they available? Can the data be accessed for review over the lifetime of the record? Now switching to the FAIR principles. And FAIR is an acronym standing for findable, accessible, interoperable, and reusable. The FAIR principles actually come original work from the geosciences, but they have meanwhile been adapted in many other disciplines. What do they mean? Data must be findable. And reusing any data is to find them, both for humans and computers. They must be accessible, knowing how they can be accessed, possibly including authentication and authorization. They should be interoperable, to be integrated with other data. The data need to interoperate with applications or workflows for analysis, storage, and processing. And finally, they should be reusable. Metadata and data should be well described so that they can be replicated and/or combined in different settings. To avoid a misunderstanding what FAIR is and is not, it's not a standard. It's not something semantic. And of course, it's not open or free. So FAIR as an acronym has a very different meaning than FAIR as in plain English. For example, data are often open access, but that may not necessarily mean they fulfill the criteria of the FAIR principles. Some data can never be open. For example, individualized patient data that can be traced back to the original patient. Nonetheless, they can be perfectly fair. By design, FAIR is not explicit about data quality, trustworthiness, responsibility, ethics, or similar points. It's just a means to look at stored data. So, what is the big difference between FAIR and ALCOA? FAIR focuses on metadata. It originates from the FAIR data principles drafted at the Lawrence Center workshop in Leiden in the Netherlands in 2015. And they have been summarized upon launch in a Nature article. In contrast, ALCOA focuses on data integrity. The origin are FDA, WHO guidance, Section 9 of Good Documentation Practice. And with that, thank you for your attention. If you have not done so yet, please also watch part 1 of this video for general ALCOA recommendations.